Welcome to my show. And today I wanted to discuss with you some findings that I had recently of a turn of the century pipe which I encountered. Now, what happened here, this is a 1/2 inch steel pipe, and you can see the threads have been sheared off, and this is where the remains of the threads are. This piping, as near as we can figure, was put in 1904 and was part of a Brumel system. At some point, somebody replaced the Brumel with this Warren-Webster valve. The Warren-Webster valve failed, and the customer had an extra valve of the exact same type. This is a post-war version of their steam, two-pipe steam radiator valve. And he went to take it off, and it just wrung right off. And something a little unusual about this pipe. And let's take a look at the, see if we can get a close-up. And I think you can see that there's sort of a fibrous, right here, there's sort of a fibrous texture to that pipe, a linear unit. And I started to suspect that this pipe might be wrought iron. And this is what happened to it. It split along the pipe seam. You take a look here, you can see that this is weakened and was weakened for a long time because there's rust there. This is where there is no rust, and that wasn't, the weld appears to be intact. And then this here was rusted and was also weakened. I've seen this before. This happened to me in Frederick when I took apart a 2.5 inch T off of some old pre-Great War pipe, and the thing split like this. It was very annoying, to say the least. It was totally unexpected. I didn't really apply all that much force, and the customer reports, and they had a holdback wrench, and it just came off almost like magic. So this sort of failure, this seam failure, is something to watch out for, particularly on old pipe, which may be wrought iron. The other indication it might be wrought iron is this weird sort of laminate. So when we cut the pipe, and I put on a mega press and then regular steel, and then installed the customer supplied valve on the radiator, and it was successful, was tested, and so forth. Then we figured we'd do the see if there was any difference in the. If you look on YouTube, you can see where people have used the grinding test. So the customer had a grinder. Power grinder down in his basement workshop, and we hit it here, and then we had the other nipple, the regular steel nipple, and hit it. We both looked at each other, and you both said, I don't see any difference. So the grinding test, at least for us, was not definitive, but I would say that this sort of laminate splitting is pretty indicative of wrought iron. And let's see if we can get a close-up. Right about there. I think you look really closely, you can see this sort of fibrous structure and this splitting along here, this layering, which is, I don't think you see that on regular steel pipe. That is pretty indicative of wrought iron. Here's a book from the 30s talking about wrought iron. Probably is one of the, wrought iron was on its last legs, as it were. People weren't using it anymore as much, and so this was an attempt to try to bring it back and talk up the wonderful list of wrought iron. And this is showing the typical fractured pattern of steel. We've all seen this crystalline structure when steel breaks. And then this shows the classic wrought iron, layered, sort of, as it says, hickory-like structure, fibrous hickory-like structure. And the fibers are actually silica slag, which is actually, instead of the slag being taken off when they make the iron, they actually pound and mix the slag and draw it out like toffee inside the layers of almost pure iron and the silica, which is how that works. There's your information on the wrought iron there. Then I also wanted to share with you one of the first times I've actually seen wrought iron is this piece of pipe, which was removed from the Bromosulcer Tower when I was working on it to rebuild this unit. Now, this pipe is a little unusual in that it is actually four and a half inches, a little over 4.5. Right there is 4.5-inch pipe. So it's that weird size between 5 and 4, which they made up until about the 1920s. It disappeared by very shortly after World War I. And when you take a look here, so this was the pipe that was broken off, and then I cut this more or less flush. It was inside of a pipe chase, so it was a little difficult to make a truly parallel cut. Then I had a welder weld on a 4-inch nipple, half nipple as it were, and the 4-inch nipple fit almost inside of this pipe. And so we were able, it was a little difficult. The welder had a little difficulty getting behind there because there was very little space with his arc. But that's a story for another day. But here I think you can see the fibrous nature of the wrought iron and the layering, the sort of plate-like tree ring, as it were, layering of the wrought iron. Now, this was put in sometime between 1907 and 1911, and it had steam blowing up through it all the way up until about 2007. And you can see there's hardly any scaling or rusting at all, and that's wrought iron for you. It tended to resist the action of steam, as opposed to regular steel at the time. The steel at the time it still had a bad reputation. It was definitely cheaper, but the iron pipe, the pipe mills of the day were used to using wrought iron. Wrought iron is great material, as any of the blacksmiths on YouTube will talk about. They really get excited about wrought iron and its properties of basically beating it into shape. This is an example of it here, as I said before, and why this was specified in 1907 as opposed to steel, even though this was more expensive, was that I believe this was, the Bromosulcer Tower was engineered by a fellow by the name of Henry Adams, who was born in the 1860s in the Kingdom of Prussia, and emigrated to the United States in the 1880s, I believe, as a fairly young man, trained in engineering, and went on to design the heating systems inside of many government buildings. And then they, of course, some prestige projects like the Bromosulcer Tower. And the engineering company that he founded is actually still in existence, and is headquartered in Towson, Maryland, not too far from where world headquarters of all steamed up is. So I wanted to share that with you, and I hope that you found this somewhat interesting. Be well and stay safe.